right, class, so the most commonly used measurement of variation is standard deviation. And what the standard deviation is it's the one variable that statisticians use to describe the variation of a data set. Okay, it's the most commonly used way to describe variation. So the standard deviation formula can look a little complicated. Luckily for you guys, your graphing calculators can do this, and I have uploaded the manuals for your graphing calculators for you. But let's break this definition down piece by piece. So the symbol S, also sometimes represented with the Greek letter sigma, is the conventional symbol for standard deviation of a sample. X bar, that's how we read this, it's read X bar, is the average, otherwise known as the mean. X is each specific data value in our data set, and N is the total number of data values, and then we subtract 1 from this. So this is also our sample size. So I'm going to go through an example where we go through this step by step by step. I do not expect you to do this by hand. I do expect you to use your calculator, okay, just to make sure you're getting the answers correctly, right? And they're a tool and we should know how to use them. So the first thing we do is what we have to do is we have to find the mean of our data set. So we need to find our X bar. Then what we do is we find the deviations from the mean for each data value. So we take each data value minus the mean. Then what we do is we square all of the deviations from the mean. We take the sum. This is a capital Greek letter, sigma. Sigma. And it means take the sum. So that means add everything together. Then what we do is we divide the sum by our total number of data values minus 1, and then we take the square root of this answer. And that gives us our standard deviation. So why don't I go through step by step a smaller example. So let's calculate the standard deviation for the following sample scores on a 15-point quiz. So the first thing I have to do, here are my scores, 11, 9, 8, and 15. I have to calculate the mean. So I'm going to take 11 plus 8, 9 plus 8 plus 15 divided by 4, right? Because 4, that's my sample size. That gives me 10.75. My next step is I need to take each of my data values minus the mean. So I'm going to take 11 minus 10.75, 9, minus 10.75, 8 minus 10.75, and 15 minus 10.75. Now for these I have some positive numbers and some negative numbers. Okay, so what we're going to want to do is we're going to want to square them because it makes all of our numbers positive. So I'm going to take the square of all of those. So I square 0.25, I get 0.0625. I square negative 1.75, I get a positive number. Negative 2.75, positive number. And 4.25 squared is a positive number. So then I just take the squares. The next step is I need to take the sum of the squares. So I have to add together what I had found before on the previous slide, right? I'm adding together all of these. Oops. Plus this, plus this, plus this. And that's going to give me 28.75. Now I have to take 28.75 divided by the number of data values, which we said was 4 minus 1, so really by 3. And that's going to give me 9.568 ... right? It goes on and on forever. This is an irrational number, right? Meaning it can't be represented as a fraction. So I go ahead and take the square root, and that's going to give me 3.096. And yes, I rounded. I would recommend always rounding to at least 2 decimal places, sometimes 3. So that's it. Those are the steps for calculating the standard deviation by hand, but luckily you do not have to do that. You have a calculator. One thing you might want to do is, I have this example here. I suggest you calculate it by hand and calculate it, maybe not by hand, but make sure when you put it in your calculator you get the same answer I did, you can also check your work by hand, but that's really unnecessary. Don't make more work for yourself than you need to.